For thousands of years, we've looked up at the moon, a silent, silvery companion in our night sky. It's inspired poets, guided travelers, and sparked our imagination. But today, the moon is so much more than just a beautiful sight. It's a bustling scientific laboratory, a cosmic time capsule, and a stepping stone to the stars. Let us dive into the incredible science happening on the moon and discover how it is shaping the future of humanity. Why are we so obsessed with a big rock floating in space? Because that rock holds the keys to our own past. The moon is about 4.5 billion years old, nearly as old as the Earth itself. It formed from the debris of a massive collision between a young Earth and a Mars-sized object. Since then, it has remained geologically quiet, preserving a pristine record of the early solar system. By studying the moon's surface and the rocks brought back to Earth, scientists can literally look back in time. They can understand what conditions were like when our solar system was just getting started. A history that has been completely erased here on Earth by billions of years of weather, volcanic activity, and plate tectonics. Think about the legendary space missions that have changed our understanding of the universe. The Apollo missions, for example, were not just about planting a flag. They were a scientific goldmine. The astronauts who walked on the moon were also geologists, collecting nearly 400 kilograms of lunar rocks and soil. Analyzing these samples back on Earth has revealed incredible details about the moon's formation, its volcanic past, and the history of asteroid impacts that shaped our entire solar system. More recently, missions like India's Chandrayaan and NASA's Artemis program are continuing this legacy, using advanced rovers and sophisticated instruments to explore new regions and uncover deeper secrets. One of the most exciting discoveries in modern lunar science is the presence of water. For a long time, the moon was thought to be completely dry, but recent missions have confirmed the existence of water ice tucked away in permanently shadowed craters near the lunar poles. This is a game changer. This water isn't just for future astronauts to drink. It can be split into hydrogen and oxygen. Oxygen for breathing, and hydrogen and oxygen together make powerful rocket fuel. This means the moon could one day become a cosmic gas station, a place where we can refuel spacecraft for missions deeper into the solar system, like to Mars and beyond. This discovery has transformed the moon from a desolate landscape into a valuable resource hub for future space exploration. Beyond its resources, the moon is also a perfect platform for looking out into the cosmos. Imagine trying to take a picture of a faint star on a foggy night in the middle of a city. That's what it's like for telescopes on Earth. Our atmosphere blurs images, city lights create noise, and weather constantly gets in the way. The moon has none of these problems. There's no atmosphere, no weather, and the far side of the moon is permanently shielded from the radio chatter of Earth. This makes it the most ideal location in our neighborhood to build incredibly powerful telescopes. We could observe the faintest, most distant galaxies, listen for clues about the Big Bang, and maybe even search for signs of life on distant exoplanets, with a clarity we can only dream of from Earth. But while we're looking out into space, the moon also gives us a unique opportunity to look inward at ourselves. Specifically, how does the human body react to living in a low-gravity environment? The moon's gravity is only about 1/6 of Earth's. Spending long periods there has profound effects on the human body. Astronauts experience bone density loss, muscle weakening, and changes to their cardiovascular system. Studying these effects is crucial. The research conducted on lunar missions helps us understand these health risks and develop countermeasures, like new exercise regimes and medical treatments. This knowledge is not just for keeping lunar explorers healthy. It's essential for planning the much longer journeys to Mars, which could take years. What we learn about human physiology on the moon will directly enable our expansion across the solar system. Pushing the boundaries of lunar exploration requires cutting-edge technology. It's not just about astronauts anymore. We are sending advanced robotic explorers, AI-driven rovers, and sophisticated satellites to do the work. These machines can venture into dangerous areas humans can't, like the deep, dark craters where water ice is found. They can operate 24/7, collecting vast amounts of data and sending it back to Earth in real time. This combination of human and robotic exploration allows us to cover more ground, conduct more complex experiments, and build a comprehensive map of the moon's resources and geology. Technologies developed for these missions, from autonomous navigation to super-efficient power systems, often find their way back into our daily lives here on Earth. Another critical area of research is space radiation. Outside the protection of Earth's magnetic field and atmosphere, astronauts are exposed to a constant stream of dangerous radiation from the sun and deep space. The moon offers a natural laboratory to study this radiation and test new shielding materials. By placing sensors on the lunar surface, scientists can measure the radiation environment and understand its long-term effects. This data is vital for designing safer spacecraft and habitats, not just for the moon, but for any future long-duration space mission. Protecting our explorers is a top priority, and the moon is helping us learn how to do it. So, what does the future hold? Scientists and space agencies around the world are planning to build permanent research stations on the moon. Think of them as the next generation of Antarctica's research bases. But in space, these lunar outposts would support long-term scientific experiments, from geology and astronomy to biology and physics. They would be a home for rotating crews of astronauts, a testbed for new technologies needed for living on another world, and the launch pad for the first human missions to Mars. The moon is poised to become the first off-world settlement for humanity, a crucial first step in our journey to becoming a multiplanetary species. Ultimately, the science we do on the moon isn't just about space. It's about us. The challenges of lunar exploration drive innovation in materials science, robotics, medicine, and computing. The quest to understand the moon's history helps us better understand our own planet's past and future. The moon is a symbol of human curiosity, a testament to what we can achieve when we work together and push the boundaries of what is possible. It reminds us that our potential is not limited to this one world. As we continue to explore our celestial neighbor, we are not just unlocking the secrets of the universe, but also unlocking the future of humanity itself. The journey has only just begun, and the moon is lighting the way. Thanks for watching. If you're as excited about the future of space exploration as I am, make sure to hit that like button and subscribe for more deep dives into the science that is shaping our world and beyond. See you in the next one.